Okay. So can you see this? Can you see my screen?
Yes, I can. Yes, I can.
Okay. So this second module we will be talking about electronics for innovators. So the reason why this is really important is we are going to learn how to build mechanical systems or something like a robot. And by doing this, you are going to learn, you are going to use some electronics components like motors, you're going to use resistors, you're going to use wires. So just getting you a good foundation. So why should you learn electronics as an innovator? You are going to, it will give you a good foundation for your engineering courses. If you take electrical engineering, if you do mechatronics like you want to do, if you do computer science, IT, even if you do civil engineering, this will give you a good foundation. You are going to, you I know in physics you learned things like Ohm's law, isn't it? Yeah, yeah. You learn things like Ohm's law. You learn a lot. Did you learn about Kirchhoff's voltage law?
Ouch.
Kirchhoff's law?
No.
Okay. Ampere's law? Ampere?
No.
Mm,
You only learned, I think, Ohm's law.
Ohm's law?
Another law you learned.
Faraday's law?
Yeah, about Faraday's law.
Then you also learned Lenz's law for magnets.
Lens law, yeah, yeah.
Yes. So there are some laws that are in physics that are very important for an engineer, such as Ohm's law. So you it also give doing electronics will give you a good foundation of how they work in a real application. Then also, as a young innovator, you know, you want to make something, you want to make a medical system, you want to make something to monitor farm or your business, your chicken farm. You can be able to use this electronics to build it. Also, as a scientist, for example, if you are learning soil or environment, you want to measure what is the pollution of in the lake, or what is the level of gas pollution, what is the level of water pollution, you will use what are called sensors. Okay. So,
Okay.
yes, so those sensors, you can buy them yourself, you connect them, you provide them with power batteries, and then it will collect data for you. Also, you can also build cool products. You know, nowadays there are things like electric toothbrush. There is like even electric cleaning, a robot that can clean the house, like vacuum cleaner. There are so many things that people nowadays there is heart, like some watches which can monitor you are running. So you can think of some cool idea, and then with the knowledge of electronics, you'll be able to build it. Okay, you can also even repair. You know, if you have a broken TV, you have a broken radio or a heater or anything electronic, with some knowledge on electronics, you can be able to at least do repairs and also build them. But also for our case, home automation, we've talked about it, robotics, if you want to repair home equipment, and also what you have to know that it's also a hobby. Even I have seen people who are they are medical doctors, but they are playing with electronics. They are opening. They have got a toy car, and then they play around with it. They open it. They want to know what is inside it, and then they repair it. They change the batteries. They change so many things. They, if it is broken, they stick. You use glue to put it back together. But also, it can also be expensive. You know, if you start playing around with a few things there. Okay.
Yeah.
Yeah. So,
Yes, yes.
but it's a lot of fun. I do it as a hobby also, and it's a lot of fun. So, uh, the basics, we are going to learn about the basics. What is electricity? Sources of electricity. We have got both the domestic and industrial sources of electricity, or electricity in the homes and electricity in industries, in workplace. And then there are key key things which current, voltage, and the Ohm's law. How do we say V is equal to I R? Do you remember? Do you know this? V, voltage, is equal to
Voltage,
current,
current times what do you call it?
resistance.
Resistance.
Okay, and then power,
IV G.
I squared R, or IV, isn't it? Voltage times current, isn't it? Yeah.
And then heat is IV. Okay.
Yeah.
I was confusing with heat. Heat in the electrical heat is IVT.
Yes,
Multiply times
IVT.
time.
Yeah. So the time element is how much time. Power is the same, but this is a matter of time. If you are measuring the rate, power is rate of doing work. Energy, like the electrical energy used, okay, over time, okay? That is power. Power is the rate of doing work, okay? Yeah, so this kind of equations, we will not go deep into them because you will study them in physics or in engineering class, but also you just need to know what is what is current, and then the concept of magnet, conductors and non-conductors, then semiconductors. So let's start. Electricity is a form of energy. It's a form of energy that we are using it for heating, lighting, industries, like even right now, charging your phone, watching if you are domestic, like in your television, your fridge, they use electricity. Heating is like your electric heater, or there are some stove that you coil that you can use to cook or to warm water. The kettle, electric kettle. Lighting is the light in your house. Then music also, you can have the domestic appliances, TV, music system, telephone, all those, they use electricity. You know that, isn't it? Yeah, Leslie, electricity as a form of energy, isn't it?
Yes.
Yes. Okay, then for domestic or even industrial users, we have got the sources like solar power, mains electricity. We just call it as mains electricity, but you know that mainly mains electricity is hydro. Do you know hydro? From the dams, from water, okay? From the water, or hydro from the dams. There are also geothermal. Geothermal. Geothermal is another source. Okay, there is wind turbine. Wind turbine. Okay. Then also there is diesel. Diesel generators is also very common in industries and locally. And then the batteries. Batteries is also very common in these areas. In like batteries, we have got the car has a battery, and also there are also some powers. Houses nowadays are required to have what is called a UPS, or in offices. Do you know what a UPS is?
It's like a backup.
Yes, it's like a backup. In
I
short, it's
knew
called uninterrupted power
power supply.
supply. Yes. So UPSS, it's basically a big battery, like it can be even 24 volts, 24, or even 12. There are others which I think is 48. And then they have some electronics. That is why we are learning electronics. They have some electronics, and then you plug it into power. You plug it into the socket. and then it charges, the battery charges. Okay. And then you connect your computer or any other equipment you want to operate, so that when there is power cut from, like this blackout in the mains electricity, the UPS kicks in. You say it kicks in, or it substitutes the power from the mains or from the socket, so that you can work for maybe 2 hours, 3 hours, 6 hours before electricity returns. So that is what is called UPS. So it's also a source of electricity. Batteries are what is inside there. Then current is the flow of electrons. The flow of electrons in a conductor, or current is just the flow of what's called electric current, which is flowing. So if you have got a battery, you have a battery like that, a positive and a negative this side, and then you connect a bulb. Normally you represent it like that, and then there is a wire from the bulb. Normally you need to put on a switch, or you need to have a switch. So when you turn on the switch, then where inside the negative, there are negative charges or electrons, isn't it?
Yeah.
Yes. And then this side, there is the positive charges.
Positive charges.
Yes. So the electrons, they move from this side towards this side, isn't it?
Yes.
Yeah. So that is the electrons. But the current is in the opposite direction. Did you learn about that?
Yes, yes.
Yeah, the flow of current is said in the opposite direction, or from the positive to negative. That is the flow of current. Then, so that's the flow of charge. There is the flow of charge. Actually, you should not say electron, you should say the flow of charge. Okay, the flow of charge in a conductor constitutes the current. And the SI unit is, do you know ampere?
Yeah.
Yes. Okay, then there is voltage, which is the potential difference. So if you have got a battery which is maybe 12 volts, and then here we think of it as having zero potential, or 0 volts. If you have somewhere which is 0 volts, and then we have 12 volts here, then the voltage or the potential difference is the energy used to transfer to move charge from the low, there is a point of low potential difference, to high potential difference. So if you move charge from there to here, that is the potential difference. The energy required to move charge, electrical charge, from a point of low potential difference to a high potential difference. Then conductors, conductors, they allow electricity to pass through them, and then non-conductors don't. Then there is semiconductors, which is in there between. Okay, so semiconductors are in there. So first activity, it's very simple. Conductors. Do you remember the conductors? Copper.
Yeah.
Okay. Iron. Okay.
Yeah. Yeah.
Zinc. Basically the metals. Okay.
Most metals.
And then brass.
Copper,
Copper.
steel.
Steel. Aluminium. Okay. Okay. These ones are good conductors. So conductors are also further like divided. You can say good conductors and poor conductors. Do you know that water also conducts electricity? Okay.
Yeah.
Yes. Like in pure water or distilled water does not. But water, just like tap water, conducts electricity. That's why people get shocked when you touch like an electric outlet with wet hands.
Also, distilled water does.
Distilled water,
Yeah,
why does it conduct?
because it doesn't matter if it's tap,
Mm.
because of what's it called? Water has both positive and negative.
So water has both positive and negative ions.
And the negative, yeah. So the hydrogen and the oxygen.
Mm-hmm.
So it still can.
Okay, okay. Okay. I wanted to find out
Yeah.
why why pure water, you say pure water does not conduct
Mm.
electricity. When we talk about pure and distilled water, we mean more or less the same thing. Okay. Are we together?
Yeah, yeah.
Yeah. Find out why distilled or pure water, does it conduct or does it not?
Ion.
Yeah. Find out. Okay. Then non-conductive. They are the things which do not allow. Like we have plastic. Is it? We have rubber. You know rubber. Then there is glass. There are so many wood. Like dry wood. There are so many things which are paper. Paper and wood are just more or less the same because paper is made of wood. Okay, glass, we looked at that. Okay, they don't allow electricity to pass through them. So those ones are basics. So we want to learn about electric components. The key, I think, from here, what we needed is electric components. So there is resistors, there is switches or buttons, there is diode, there is motors, there is wires and jumpers, breadboard, and then we'll also learn about breadboarding basics or what are called breadboard. Okay. Did mom buy those things or she has not bought them yet?
Not yet.
Not yet. Okay. So
But
we
she
are going
will soon, like maybe next week.
okay. So we are going to do a few things here and then when she buys them, we will we will
Such.
yeah, yeah. So okay, so I want you to go to this site. So yeah. There are several online circuit simulators. Okay.
Yeah.
So one of them is called Circuit Lab. Okay. So I want you to go to, you have your, or you go to the chat, look for the chat, and then you go to, can you?
Yes, I'm there.
Yes, yes. So there are very good websites which some people have developed. So, circuit lab whereby somebody puts a circuit. You can sign in. They want us to create an account. I don't want to create an account now, but you can create an account later. Okay. Do you see these components that are here?
Yeah, yeah.
Yes. So we are going to just go through them. So this one is ground, or let's start. We can start with a new, just a new, and then they have a book there. We don't need. Okay. We have a voltage source. Do you know voltage source? Okay. Do you see that? Can you see?
Yes, I can.
Yes, so you go there and then let us say we provide 9 volts. Let's say it is a 9 volts battery, like those batteries. Okay.
Yeah.
And then, so this is a battery. That's how you put a battery. And then we want to look for a switch. So I want you to look for a switch. We want you to look for a switch. A switch. So this, you use this one. That's the representation of a switch. And then we look for a voltmeter, basically voltmeter. And then also because we have a voltmeter, we can also put a ammeter, and then you can rotate. You press R to rotate. Actually, this website is really good. So we have got a voltmeter is for measuring voltage, and we put a voltmeter across the source of power, and then switch, and then we put ammeter, and then finally we are going to put some two things here. We have got a diode, LED, light emitting diode. Do you know LED?
Yes, yes.
Yes, LED, when you pass current through it, it lights. And normally it's good to have a resistor between the LED and the source. So we're just having a resistor like that. So we put a resistor. Okay. Okay. Then there is what is called ground. So you should put ground this side like that. Then do you know how to connect them? Do you know you use a wire?
The wires.
Yes, you use a wire and then you connect. Isn't it? It is easy. Yeah. Do you see?
Yeah, yeah, yeah.
And then we need to measure voltage across our source. Okay. And then you connect this is ground. You connect it there. So in short, voltmeter is measured across the source. Do you see? Do you see?
Yes, yes, I can see.
Mm.
Yes, I can.
Yeah, yeah, yeah. There's something here which I wanted to. You can also delete a wire. You can copy. You use Control C to copy this, and then V. You put it there. And they're telling you there is a book here. You can download. You see schematic. They're telling you how to do a simulation, how to do all those things. I think this is the one which we want to do. We do 5 volts. Only 5 volts is okay. Okay, and then you can connect this here. Okay, and then if we put ground here and ground here, it means that they are connected. All of them are connected to ground. Are we together? Can you see? Yes. But also if you put a wire from here to here, doesn't matter, but it's good to just put it like that. Okay, so this is a voltmeter. It's used to measure the voltage across the power source. And we have used a DC voltage, not AC, DC voltage. Okay. And then current there. And then this is a switch. And then we have got a source of a current measurement unit or ammeter, and then a resistor, and then we have an LED. Then we come to DC simulation. Then they have got what is called a DC simulation. I don't want to go. I don't want to go deep into this because this is like more like advanced electronic stuff. Okay, but you know that if we turn on the light, when we turn on here, then the LED should be able to light up. This is simulation successful. Okay, so these are some of the softwares which electronics used, but I just wanted to use it to show you the various components that we have. We have transformers, we have these gates, don't worry about them now. There are so many things here. There is a buzzer, a speaker, there is light sensor. Okay, can you be able to see that? There is a capacitor. You know what a capacitor is, isn't it? There is also what is called an inductor, which is just a coil of wire. There are so many other things. There is what is called diode, Zener diode. So you can be able to make a circuit. You can be able to make a circuit with such softwares, and then you learn how to do electronics. Can you be able to see that? Can you be able to see that?
Yes, yes. Sorry,
Yes.
my computer.
Yes, yes. So this is what is called a circuit simulator. It is used to simulate a circuit. Or these are the electronics. So what we've done here is what is called a circuit, or it has got these components, and then you put them together with a wire. Okay. There is a similar one. There is one which we are going to use, which is called walkway. So I want you to also go to this page. This is what we will use mostly. Go to walkway. I've sent you the link. Walkway. Can you open it?
That's it.
Yeah. The one I have sent you. Okay.
We understand that.
Yeah, this is what we are going to use mostly. And we can add a part. And then I want you to add something called breadboard. We want to learn about breadboard. We want to learn about breadboard. Just use.
You can search. Wait.
Yeah, you can search.
Add a new part. Okay, okay.
Yeah. So then you look for the full breadboard.
There's
And by
manifold. I can remember.
this thing, you can rotate it like that.
Yeah, manifold. Okay.
Mm.
I've added to
Yeah.
how do you remove one?
Then you can add LED. I want you to add at least 2 LEDs. add another LED, and you can change its color, by the way. So I want you to add three actually. One will be blue, and then you give them some space, and then add another one, blue RGB. This other one, make it green. Can you see that?
I can't see your screen.
You can see my screen.
I can't.
Okay, sorry. Can you see now?
Not yet. Hasn't yet loaded. Give it a minute. Wait, how do I remove a device? I've added two breadboards.
Or you just delete. Now can you see?
That's the delete button. No,
Now you can see.
no.
Ah, showing me that.
Okay.
Eh?
He said I had a breadboard and LEDs, two LEDs.
Yeah. Can you see my screen now?
Not yet.
Then what's the problem? Stop sharing. Let me share again. And now?
Yeah, it's coming. Um, yeah, it just coming. You can see my screen.
Okay.
Yeah.
Okay. So I want you to have at least two, two or three. Just do two or
How do
three.
you, how do you change? Oh, okay, I can see how you change the color. So,
Yeah.
yeah, just had to try that.
So we have got what is
What
called
exact?
LED. Okay.
I place it at 1 at 10 and 1 at 15.
Yes. You can put just giving space, and then we are going to add something called resistor. Also, you put resistor.
Yeah.
The value don't worry about now. Okay. And then you can click R to rotate it.
So,
And then you connect it to the long side. We are coming to learn which side is positive. So I just want you to copy it. You can copy, by the way, Control V, and then you paste like that. Okay. Can you see that? Hello, Leslie, can you see? Hello, Leslie, can you see?
yes, I can. Yes, I can.
Okay. Then LED, if you look for LED, pin LED terminal from your electronics, from your physics, positive is normally the long one. Are we together?
LEDs.
Yes.
Okay.
Yes, but in other cases they may be different, but the positive normally is the long side is the positive. Okay.
So it is negative.
So now this one should be on the long side. The long side is the one which is bent. Can you see that one which is bent?
But it's long. Okay, yeah.
Yeah, it's longer. So put the resistor there.
And on that side.
Yes, and then you will come to this thing called Pico, and then you connect GND. You'll connect GND ground. You connect a black wire there. Can you see that?
Even one.
You come here to the third pin. There is GND. 1, 2, 3. You
That's a
can
motherboard.
yes.
That's
This
a
is a motherboard. We are coming to learn what it is and how to use it. Okay.
okay. Like, how do I get it?
So you click here.
How when I search? How do I search it? Because I don't have it in
Pic,
my.
Pico. Is it not appearing as Pico?
No.
Okay, let me share mine.
You can just hover on the, I think.
Yes, yes. I can share.
Try just hovering. Try hovering on your motherboard. You can see the name maybe.
Or no, the best thing is go to the site which I have shared with you, and then you will see my project the way it is. Quickly
Um,
click onto that into a new.
okay, I can see yours now.
Yes, yes. So do you have it the way it is?
Ye- Like on my screen, yeah.
Yes. So we work from this one, okay?
Okay.
Okay. So we are having 1 minute remaining. We are coming back to start learning what this is all about and how to connect them and how to. You are going to be writing some code here, okay? Okay. Hello.
Okay, it's okay.
Yes, yes. So this is where you are going to be writing code, and then you click here. Can you click on this simulate or this green button? Then you will see down here it has written hello Raspberry Pico. Can you see?
Yeah.
Okay.
Yes.
So I want you to change there, put your name. Maybe hello from Leslie or hello from Bob. Can you
Oh,
see?
now the coding now. Okay.
Here in the coding part.
Okay.
And then you click there. Okay. Hello. Hello, Leslie.
Yeah.
Yes. So let's take the break and then we'll come and continue from there. Okay.
Yeah. Okay. Okay.
Okay.